Hi, in this video we're going to use Pythagoras theorem combined with surds. Now remember what a surd is, it's just a square of a number, and if you haven't seen my videos yet on how we manipulate surds, please do watch those first, but we will try to briefly recap that in this video. So what have we got here? We've got this right angle triangle, and we want to find the exact value of x in simplified surd form. Now let's remind ourselves how Pythagoras theorem works. Pythagoras theorem is this. So this is how you spell it. But basically, it relates to side lengths of a right angle triangle. Now, if you were to have one of the shorter lengths of the right angle squared, and then add the square of the other shorter length, it gives you the length of the hypotenuse squared. So let's say that these two shorter lengths we call A and B, and the hypotenuse, which is the longest length of the right angle triangle, we call C, and remember the hypotenuse is always opposite the right angle, then Pythagoras theorem says that one of the shorter length squared plus the other shorter length squared is equal to the length of the hypotenuse squared, like that. So that is what we're going to use for this question here. So we can see from our diagram that the A here is the x, so we're going to substitute the A for x, so x squared plus the other shorter length squared, so B is 3, so 3 squared, is equal to the length of the hypotenuse squared. Now the hypotenuse, the C here, is 6, so we can put 6 squared. And now we just need to solve this. So 3 squared is 9, 6 squared is 36. We want to get x on its own. X is being squared, then we're adding 9. Let's undo the plus 9 by subtracting 9 from both sides. 36 minus 9 is equal to 27. And then to get rid of that squared on the x, we do the opposite. We square root both sides, so x is the square root of 27. Now, we want this in simplified surd form. So we want this surd here, the square root, to be as simple as possible. That means for the number under the square root to be as small as possible. Now, the way we do that is to use this law of surds here. If you have the square root of one number and you times it by the square root of another number, you times them together. But you can actually use it backwards as well. So we can split the AB, we've got a product of two numbers, into the two separate numbers that times together to give that. Now, what we do here is with the root 27, is we think of the biggest square number that's a factor of that number. What's the biggest square factor of 27? Well, it's 9. So what we do is we can write this as root 9 and then root, and then 9 times what is 27? Well, it's 3. So we can write root 27 as root 9 root 3, because as per this rule here, if we had root 9 times root 3, it'd be root 9 times 3, which is 27. So that's why this works. The reason why we put the square number first is because then the square root of 9 is 3. So we can write that as 3, root 3, and now that is in simplified surd form. So that is the final answer.